They called it the workhorse of the Wehrmacht, the German Sd.Kfz 7 heavy tractor, a machine that had towed 88mm flat guns across Europe and hauled supplies through Russian mud. American soldiers had seen these massive half-tracks abandoned on roadsides, disabled in combat or captured intact as the German war machine crumbled. But they had never actually driven one. Not really, not until the spring of 1945, when GI crews finally climbed into the driver's seats of these captured German tractors and fired up their Maybach engines. They expected German engineering excellence. They expected power and reliability. What they discovered instead would fundamentally change how American military planners understood the hidden weaknesses that had helped doom the Third Reich. Weaknesses that went far beyond tactics or training or even industrial capacity. Sometimes the most revealing truths about an enemy's collapse are found not in the grand strategic decisions, but in the mundane details of how much fuel a truck burns per mile. By late 1944, the tide of war had turned decisively against Germany. American, British, and Canadian forces had broken out of Normandy and were racing across France toward the German border. Behind them, supply officers worked frantically to keep fuel, ammunition, and spare parts flowing to the rapidly advancing armies. Every gallon of gasoline had to be shipped across the Atlantic, offloaded at French ports, and trucked hundreds of miles to the front lines. Fuel economy was not just a peacetime concern. It was a matter of operational success or failure. The American military had standardized on a family of half-track vehicles for its mechanized infantry and artillery support. Chief among these was the M3 half-track, a vehicle that would become as iconic to the American war effort as the Sherman tank or the Jeep. Produced by the tens of thousands, the M3 was powered by a white 60 AX engine, a six-cylinder gasoline engine that produced 148 horsepower. It was not particularly powerful by the standards of heavy trucks, but it was reliable, relatively simple to maintain, and most importantly, it could be mass-produced using components from American commercial truck manufacturers. The M3 could carry a driver and 12 soldiers in its armored body, or tow light artillery pieces. Its 60-gal fuel tank gave it a range of approximately 220 mi on roads before refueling. Do the math and you get roughly 3.7 miles per gallon on paved surfaces. Off-road through mud or sand, that figure dropped considerably, sometimes to as low as 2 miles per gallon. American soldiers knew their half-tracks were thirsty machines, but they accepted this as the price of mechanized mobility. The German Sd.Kfz, by contrast, was a different beast entirely. Developed in the mid-1930s as part of Germany's program to create a family of standardized military tractors, the Sdkfz was designed to tow heavy artillery pieces, particularly the famous 88mm Flak gun and the 15cm SFH-18 howitzer, where the M3 was built for carrying infantry. The Sdkfz was built for raw pulling power. The Sdkfz was powered by a Maybach HL62 2K engine, later upgraded to the HL64TR. These were six-cylinder water-cooled gasoline engines producing 140 horsepower, remarkably similar in output to the American White engine. But here is where the similarity ended. The Maybach engine displaced 6.2 L, later 6.44 L, significantly larger than the American unit, and it consumed fuel at a rate that would shock American maintenance crews. German technical manuals listed the Sdkfz-7's fuel consumption at approximately 80 L per 100 kilometers on flat roads. That works out to roughly 3 miles per gallon. But this was under ideal conditions with an experienced driver on good roads with moderate loads. Cross-country through the mud and snow that characterized much of the Eastern Front, fuel consumption could skyrocket to 160 L per 100 kilometer. That is a staggering 1.5 miles per gallon. The vehicle carried 215 L of fuel in its tanks, roughly 57 gallons. On paper, this gave it a range of 250 kilometers, about 155 miles per hour, on roads. In practice, under combat conditions, the Sdkfz 7 often needed refueling after less than 75 miles of cross-country travel. These were not figures that American intelligence analysts had paid much attention to during the war. After all, when you are fighting against an enemy, you care about their tank's armor thickness and their guns' penetrating power, not how many miles per gallon their trucks get. But in the spring of 1945, as American forces overran German positions and captured equipment by the hundreds, some enterprising soldiers and officers began to take a closer look at what they had seized. The story really begins in March of 1945 in the Rhineland, as American forces prepared to cross the Rhine River and drive deep into the heart of Germany. The 9th Army under Lieutenant General William Simpson had been tasked with a massive river crossing operation. Engineers and logisticians were working around the clock to stockpile supplies for the push eastward. Fuel dumps were being established, bridging equipment assembled, and every available vehicle pressed into service. It was during this chaotic period of preparation that elements of the 9th Army's supply units came across a nearly intact German motor pool that had been hastily abandoned. Among the vehicles left behind were several Sdkfz tractors, apparently abandoned due to lack of fuel, a common fate for German vehicles in the final months of the war. Unlike many captured vehicles which were damaged or stripped of useful components, these half-tracks were in remarkably good condition. A young captain in an ordnance company, a man whose name has been lost to history, but whose actions would be recorded in after-action reports, made a decision that would prove illuminating. Rather than simply cataloging these vehicles for intelligence purposes or sending them to the rear for evaluation, he decided to put them to immediate use. His unit desperately needed heavy towing vehicles to move artillery and supplies forward. And here were several perfectly functional tractors just sitting there. Why not use them? The first challenge was fuel. The Maybach engines ran on gasoline, the same fuel used by American vehicles, so that was not a problem. The Germans had naturally taken most of their fuel with them when they retreated, but American fuel was abundant. The second challenge was familiarization. None of the American drivers had ever operated a German half-track. The controls were laid out differently. The instrumentation was in German, and the driving characteristics were completely unfamiliar. But American soldiers have never been shy about figuring out foreign equipment. Within a few hours, drivers had been assigned to each vehicle, and with some trial and error and a few stalls and gear-grinding mishaps, they got the Sdkfz running and moving. The immediate impression was positive. The big Maybach engine roared to life with authority. The tracks featuring the distinctive overlapping road wheel design that characterized German armor bit into the muddy ground with impressive traction. When hitched to a heavy artillery piece, the Sdkfz 7 pulled it without strain. One sergeant later wrote in a letter home that the German half-track felt like driving a locomotive, powerful and steady, but somehow heavier and more ponderous than the American vehicles he was too used to. The steering took more effort despite the power assist. The suspension, while effective, transmitted more vibration to the crew, but the power was undeniable. Where an M3 might struggle with a particularly heavy load or difficult terrain, the Sdkfz just kept going. For the first day or two, everyone was impressed. Here was German engineering at its finest, they thought. Robust construction, powerful engine, excellent traction. Several officers began writing up reports suggesting that the Army might want to consider adopting some of these design features in future American vehicles. But then the fuel consumption figures started coming in, and the picture changed dramatically. Each captured Sdkfz had been issued a full tank of American gasoline, 57 gallons, roughly the same as an M3. The American drivers knew that their own M3s could go 200 mm or more on a full tank, even when towing artillery. So they were shocked when, after less than 90 mi of mixed road and cross-country travel, the Sdkfz's were running on fumes and demanding refills. At first, the American crews assumed they had made some mistake. Perhaps there was a fuel leak they had not noticed. Perhaps the tanks had not actually been full to begin with. Perhaps they had been driving inefficiently, revving the engines too high or using too much throttle. But as more days passed and more miles were logged, the pattern became undeniable. The German half-tracks were consuming fuel at nearly double the rate of the American M3s. The ordnance captain ordered his men to conduct a systematic test. They selected one Sdkfz and one M3, both in good mechanical condition. They filled both vehicles' tanks to maximum capacity. Measured carefully, they planned an identical route. 25 miles of paved road followed by 15 miles of moderate cross-country terrain, and then 25 miles back on pavement. Each vehicle would tow a 15-centimeter howitzer, approximately the same weight that both vehicles were designed to handle. The results were startling. The M3 completed the 65-mm circuit and still had fuel remaining in its tank. Based on careful measurement, it had consumed approximately 17 gallons, giving it an effective fuel economy of roughly 3.8 milliliters per gallon. Under these mixed conditions, the Sdkfz running the identical course, consumed every drop of its 57 gall tank and needed an emergency refill to make it back to base. Post-test analysis indicated it had burned approximately 63 gall for the same 65 mph. That worked out to barely 1 mile per gallon. Someone in the unit did the arithmetic and realized the implications. If you needed to move a battalion's worth of artillery 100 mm, and you did it with M3 half-tracks, you would burn roughly 2,600 grain of fuel, assuming 10 vehicles, each consuming 26 gall. Do the same job with Sdkfz 7s, and you would burn approximately 6,300 gall, more than twice as much. Scale that up to division level or corps level or army level, and you were talking about tens of thousands of extra gallons of fuel per day. The American officers began to understand something that would become clearer as they pushed deeper into Germany. The German military had designed its vehicles with an assumption that fuel would always be available. Germany had access to synthetic fuel plants, captured oil fields in Romania, and the expectation of rapid victories that would bring them to the oil fields of the Caucasus. They had not designed their vehicles with fuel efficiency as a priority. American military planners, by contrast, had always operated under the assumption that every gallon of fuel was precious. Oil had to be shipped across submarine-infested oceans. It had to be transported hundreds of miles from ports to frontline units. American industry had developed engines that squeezed every possible mile out of every gallon, not because American engineers were necessarily more clever, but because American logistics demanded it. The Germans had built for power and performance. The Americans had built for efficiency and sustainability. As more German vehicles fell into American hands in the spring of 1945, this pattern repeated itself again and again. The German trucks, the Opel Blitz and the Mercedes-Benz models, consistently consumed more fuel per mile than their American counterparts. The German armored vehicles, the Panther and Tiger tanks, were notorious fuel hogs, managing less than 1 mile per gallon even on roads. The German Air Force, the Luftwaffe, flew aircraft that burned through fuel at prodigious rates. Intelligence officers began collecting data and a picture emerged. The German military was exquisitely designed for short, violent campaigns where fuel could be captured from the enemy or stockpiled in advance. It was terribly suited for long wars of attrition where every gallon mattered. This had not been apparent in 1939 and 1940 when German forces had overrun Poland and France in weeks. But by 1943 and 1944, with Germany fighting on multiple fronts and Allied bombing campaign targeting synthetic fuel plants, the fuel hunger of German vehicles had become a critical vulnerability. The American soldiers examining captured Sdkfz began to notice other details that reinforced this pattern. The vehicles were built like tanks, heavy and over-engineered. Every component seemed designed for maximum strength rather than optimal efficiency. The Maybach engine, while powerful, was a complex piece of machinery with precision fuel injection systems that required careful maintenance and adjustment. When these systems were not perfectly tuned, fuel consumption increased even more. The American white engine in the M3, by contrast, was based on commercial truck engine designs. It was simpler, more forgiving of imperfect maintenance, and designed from the outset to be fuel efficient. American automotive engineers had spent decades optimizing internal combustion engines for fuel economy. Because American consumers cared about operating costs, that civilian engineering legacy paid enormous dividends when those same design principles were applied to military vehicles. Consider the practical implications on the battlefield. An American mechanized infantry company with 12 M3 half-tracks could operate for a full day's combat operations, moving 20 to 30 minutes with approximately 200 gall of fuel. The same company equipped with German Sd.Kfz would need closer to 500 gallons for the same operations. Scale that up to a division with hundreds of vehicles and the difference becomes enormous. American logistics planners had calculated that each frontline division required approximately 50,000 gallons of fuel per day for all its vehicles combined: tanks, trucks, half-tracks, and support vehicles. A German Panzer division with its less fuel-efficient vehicles required closer to 75,000 gallons per day. When Germany was winning and capturing enemy fuel stocks, this was manageable. When Germany was retreating and Allied bombers were hitting fuel production facilities, it became impossible. American soldiers driving captured Sdkfz 7s in the spring of 1945 found themselves stopping for fuel twice as often as they would in their own vehicles. They found themselves watching fuel gauges drop with alarming speed. They found themselves understanding in a visceral and immediate way why so many German vehicles had been abandoned on roadsides with empty tanks. The Germans had not abandoned those vehicles because they were mechanically unreliable. They had abandoned them because they had literally run out of gas. One particularly revealing incident occurred in early April 1945 as American forces advanced through central Germany. A supply column that included both American M3s and captured Sdkfz-7s was tasked with bringing ammunition and supplies to a forward artillery position approximately 80 mi behind the rapidly moving front lines. The mixed convoy left the supply depot early in the morning with all vehicles fully fueled. The American half-tracks completed the round trip without requiring any refueling. They returned to base with fuel to spare. The German half-tracks running the exact same route under the exact same conditions had to be refueled at the midpoint of the journey. Without that emergency refueling, they would have been stranded. The convoy commander, a major with extensive logistics experience, included this incident in his after-action report with a note that read, "German vehicles unsuitable for sustained operations due to excessive fuel consumption." This was not an isolated incident. Across Germany in the spring of 1945, similar stories were playing out wherever American units tried to employ captured German vehicles. A tank retrieval unit found that German heavy tank recovery vehicles, variants of the Sdk-9, could pull disabled tanks that American wreckers struggled with. But those German wreckers needed refueling so frequently that they actually took longer to complete recovery missions because they spent so much time stopped for gas. An artillery battalion that briefly used captured Sdkfz-7s to tow their 105mm howitzers reported that the German tractors had better traction in muddy conditions than American vehicles. But the report also noted that the German tractors required fuel trucks to accompany them on every movement, which negated their tactical advantages by increasing the size and vulnerability of the convoy. American soldiers also noted that the German vehicles' fuel tanks seemed poorly designed for the vehicle's actual consumption rates. The M3 60-gal tank was carefully sized to give the vehicle adequate operational range. The Sdkfz-7's 215L tank, roughly 57 g, was actually slightly smaller relative to the vehicle's size, but its consumption rate meant it needed refueling much more frequently. It was as if German engineers had not fully appreciated how much fuel their vehicles would actually use under combat conditions. Some American maintenance crews experimented with ways to improve the fuel efficiency of captured German vehicles. They tried different driving techniques, adjusted fuel mixtures, and tuned carburetors. They achieved marginal improvements, perhaps 5 or 10% better fuel economy, but they could not overcome the fundamental design reality that the Maybach engine in its large, heavy vehicle platform was simply thirstier than the American alternative. The irony was not lost on American tankers and truck drivers. Here they were operating in the heart of Germany with fuel being shipped from Texas and Oklahoma, keeping German-designed vehicles running. The Germans fighting on their own soil could not keep their own vehicles fueled. What did that say about the sustainability of the German war machine? German fuel production had peaked in early 1944 at approximately 5.7 million tons per year. By the spring of 1945, it had collapsed to less than 1 million tons per year, a drop of more than 80%. Allied bombing of synthetic fuel plants, particularly the concentrated attacks in the summer of 1944, had devastated German fuel production. The loss of the Romanian oil fields to Soviet advances in August 1944 removed another crucial fuel source. The German military had tried to compensate through strict fuel rationing. By early 1945, fuel allocations to frontline units were being cut repeatedly. Training flights for Luftwaffe pilots were canceled to save fuel. Tank units were ordered to minimize movement. Horse-drawn wagons and carts, supposedly obsolete in the age of mechanized warfare, made a comeback as German units tried to conserve their dwindling fuel supplies for combat vehicles. But rationing could not overcome the fundamental problem that German vehicles needed too much fuel. Even with strict rationing, German panzer divisions were frequently immobilized. They could not maneuver to respond to Allied attacks. They could not retreat to better defensive positions. They could not advance to exploit tactical opportunities. They simply sat in place waiting for fuel that never came until Allied forces overran them. After action, reports from this period contain numerous anecdotes about captured German vehicles. One report from an armored division described how a captured Panther tank performed beautifully during a short-range attack. but had to be abandoned after just 15 May because it had consumed all its fuel, and the American supply chain could not afford to keep it fed. Another report from an engineering battalion noted that captured Sdkfz-7s were useful for short-distance heavy hauling, but were being phased out of regular use because they burned fuel like it was going out of style. Some American units continued to use captured German vehicles, but only for specific short-range tasks, where their power advantages outweighed their fuel consumption drawbacks. A few Sdkfz ended up being used as static power sources, their engines running generators at forward bases. Others were simply parked and cannibalized for spare parts. The German half-tracks that had once epitomized mechanized warfare efficiency were now seen by American soldiers as examples of impractical excess. The broader lesson was being learned at every level of the American military. German equipment looked impressive, sounded impressive, and in short-term tactical situations often performed impressively. But the German military had not solved the fundamental problem of modern mechanized warfare: how to keep your vehicles supplied with fuel. The American military had solved it, not through any particular technological breakthrough, but through careful attention to logistics and fuel efficiency. General Dwight Eisenhower, the Supreme Allied Commander, had famously said that amateurs talk strategy, while professionals talk logistics. The fuel consumption comparison between American and German vehicles was a perfect illustration of this principle. The Germans had built tactically superior vehicles in many cases. The Panther tank had better armor and a better gun than the Sherman. The Sdkfz could tow heavier loads than the M3, but these tactical advantages meant nothing if the vehicles could not be kept supplied with fuel. The American logistics system, often underappreciated in accounts of World War II, was perhaps America's greatest military achievement. From oil wells in Texas and California, crude oil traveled to refineries where it was processed into gasoline and diesel fuel. That refined fuel was loaded onto tankers and shipped across the Atlantic, running a gauntlet of German submarines. The fuel was offloaded at ports in Britain or France, loaded onto trains or trucks, and transported hundreds of miles to forward fuel dumps. From there, it was distributed to division supply points and finally delivered to individual units down to the company level. This entire system, stretching from Texas to the front lines in Germany, moved millions of gallons of fuel every day. American logisticians had calculated that every gallon of fuel delivered to a frontline tank represented roughly 4 gallons total when you accounted for the fuel used by the ships and trucks transporting it. But the system worked. American units rarely faced fuel shortages in the final year of the war. The German logistics system, by contrast, had broken down completely. German synthetic fuel plants, which had provided much of Germany's fuel supply, were being systematically destroyed by Allied bombing. The Romanian oil fields captured by Soviets in August 1944 were lost. German fuel production was a fraction of what it had been a year earlier, and what little fuel Germany still produced had to be distributed across multiple fronts with railways and roads under constant air attack. But even if Germany had somehow maintained its fuel production, the fuel consumption rates of German vehicles would have posed a problem. A study conducted by American intelligence in mid-1945 estimated that Germany would have needed approximately 25% more fuel production just to match the operational tempo that American forces sustained with their more efficient vehicles. Germany's fuel-hungry vehicles were not just a problem when fuel was scarce. They would have been a burden even in a best-case scenario. The comparison extended beyond just half-tracks. American tank crews noted that captured German Panther tanks, while impressively armed and armored, consumed fuel at approximately half a mile per gallon. A Sherman tank achieved closer to 1 mile per gallon. The Panther needed roughly twice as much fuel to cover the same distance. This meant that a Panther-equipped armored division needed twice as many fuel trucks, twice as many fuel dumps, and twice as much logistical support as a Sherman-equipped division. German tank destroyers, vehicles like the Jagdpanther and Jagdtiger, were even worse. These heavy vehicles mounting powerful guns on tank chassis were tactically impressive. They could destroy any Allied tank from long range, but they were also among the most fuel-inefficient vehicles ever designed. American tankers who examined captured Jagdtigers after the war were amazed that Germany had even attempted to field such vehicles. One officer's report noted that a Jagdtiger burned more fuel sitting idle with its engine running for an hour than a Sherman used traveling 10 miles. By April of 1945, As American forces drove deeper into Germany and the Reich collapsed around them, captured German vehicles littered the roadsides by the thousands. Many were damaged or destroyed in combat, but a significant percentage had simply been abandoned when they ran out of fuel. The German soldiers had left them behind, not because the vehicles were broken, but because there was no more gasoline to put in their tanks. American intelligence officers compiled reports on German fuel supplies and consumption rates. The numbers told a devastating story. At the height of German power in 1941 and 1942, Germany had produced or captured enough fuel to keep its military machine running barely. But as the war dragged on, as synthetic fuel plants were bombed, as the Romanian oil fields were lost to Soviet advances, German fuel supplies dwindled. By 1944, German panzer divisions were often immobilized, not by enemy action, but by lack of fuel. The Battle of the Bulge in December 1944 to January 1945 had been Germany's last major offensive in the West. One of the operation's fundamental assumptions was that German forces would capture American fuel dumps early in the offensive and use that captured fuel to sustain their advance. When that did not happen, when American defenders held key fuel dumps or destroyed them before retreating, the German offensive literally ran out of gas. Panther and Tiger tanks were found abandoned with empty fuel tanks just a few miles from their starting positions. The Ardennes offensive had been planned with explicit recognition of Germany's fuel shortage. German planners calculated that they had enough fuel to reach the Meuse River, about halfway to their objective of Antwerp, but only if they captured American fuel stocks along the way. This was an extraordinarily risky assumption, betting an entire offensive on the hope of capturing enemy supplies. When the offensive began on December 16th, some German units did capture small American fuel dumps, but the quantities were insufficient for the number of vehicles involved. American defenders, recognizing the fuel situation, prioritized defending or destroying fuel stocks at Stavelot. American engineers blew up a fuel dump containing hundreds of thousands of gallons just hours before German forces arrived. The explosion was so massive it could be heard for miles. German armored spearheads, including units equipped with Sdkfz 7s and other heavy vehicles, found themselves stranded as early as December 18th, just 2 days into the offensive. Some Panther tanks covered less than 30 mi before running out of fuel. Sdkfz's towing artillery pieces were abandoned when they could not reach the advancing infantry they were supposed to support. The offensive, which Hitler had hoped would split the Allied armies, ground to a halt largely because of fuel shortages. American intelligence officers interrogating captured German soldiers after the Battle of the Bulge heard the same story repeatedly. German units had been ordered to advance, had tried to advance, but had stopped because they had no fuel. Tank commanders described watching their fuel gauges drop toward empty while waiting for fuel trucks that never came. Sdkfz 7 drivers recounted abandoning their vehicles within sight of their objectives because they had burned through their fuel just getting to the battle. One captured German lieutenant interrogated in January 1945 told his American captors that his artillery units' Sdkfz 7s had consumed all their fuel in the initial advance and had been immobilized ever since. His guns had remained silent during critical phases of the battle, not because they lacked ammunition, they had plenty of ammunition, but because the tractors that were supposed to move the guns to new firing positions had no fuel. The Americans filing the interrogation report noted with dark humor that German engineering prowess had created vehicles so powerful they could not actually be used. The fuel consumption comparison became a regular topic of conversation among American soldiers in the winter and spring of 1945. GIs swapped stories about captured German vehicles. One corporal wrote home about driving a captured German half-track, which he found impressive until he realized it needed refueling twice as often as his regular vehicle. A sergeant in a maintenance company wrote about trying to keep a captured Sdkfz 7 running and discovering that its fuel tank was empty after just 60 miles of use. These were not just amusing anecdotes. They represented a fundamental insight into why the Allies were winning the war. The American military had built a sustainable war machine. The German military had built an unsustainable one. German vehicles were often better in individual performance metrics. Faster, more powerful, better armored. But when you accounted for fuel consumption, maintenance requirements, and logistics sustainability, American vehicles were superior where it counted. American soldiers walking through those battlefields in early 1945 saw the evidence everywhere. Powerful German vehicles, beautifully engineered, utterly stranded. Some American GIs took to spray painting messages on abandoned German tanks out of gas, or thanks for the memories. There was a dark humor in it, but also a recognition of a fundamental truth. The Germans had lost the fuel war long before they lost the shooting war. The Sdkfz-7 became something of a symbol of this failure. It was not as famous as the Tiger tank or the Panther, but to the American soldiers who actually had to operate captured German vehicles, it represented everything that was wrong with German military planning. Here was a vehicle that could do things American vehicles could not do, could tow heavier loads, could traverse worse terrain, but it needed twice the fuel to do it. And in a war where fuel logistics determined success, that extra fuel consumption was not a minor detail. It was a fatal flaw. Some German officers after the war would argue that Germany lost because of Allied numerical superiority, or strategic bombing, or the two-front war. All of these factors were important. But at the tactical level, where individual soldiers and small units fought and survived or died, the fuel consumption problem was immediate and obvious. German units in 1945 were frequently immobilized. They could not maneuver, could not retreat, could not advance because they did not have fuel. American units, by contrast, rarely faced fuel shortages. The American logistics system, for all its occasional glitches and problems, kept fuel flowing to frontline units. American trucks and half-tracks might not have been as powerful as their German counterparts, but they could keep running. In a war where mobility meant survival, that made all the difference. The young captain who first decided to test captured Sdkfz-7s against American M3s probably did not realize he was documenting a major strategic lesson. He was just trying to figure out whether these captured vehicles were worth keeping. But his simple fuel consumption test revealed a fundamental asymmetry between American and German approaches to mechanized warfare. The Germans had prioritized power and performance. The Americans had prioritized efficiency and sustainability. In a short war, the German approach might have worked. In a long war, the American approach was inevitable. By May of 1945, when Germany surrendered, the American military had captured thousands of German vehicles. Some were shipped back to the United States for detailed technical evaluation. Engineers at Aberdeen Proving Ground in Maryland disassembled German engines, studied their fuel injection systems, analyzed their transmission designs. They confirmed what frontline soldiers had already learned. German vehicles were marvels of engineering in many ways. They were also horrendously inefficient in terms of fuel consumption. The Aberdeen testing was exhaustive. German engines were put on dynamometers and run through full power cycles. Fuel consumption was measured under laboratory conditions at various loads and speeds. The data confirmed field observations. The Maybach HL62 engine in the Sdkfz consumed approximately 30% more fuel per horsepower produced than the American White 160AX engine. This was not because the Maybach was poorly designed. It was actually quite sophisticated, but German engineers had optimized for power density and reliability, not efficiency. American engineers noted several design choices that contributed to the fuel consumption problem. The Maybach engine used a relatively low compression ratio, which reduced thermal efficiency. It had a complex carburetor system that often ran rich, providing more fuel than necessary to ensure reliable operation under all conditions. The engine's timing was set conservatively to maximize power output rather than optimize fuel consumption. Any one of these factors alone would have been manageable. Together, they resulted in significantly higher fuel use. The Americans also examined the entire powertrain of the Sdk-7. The transmission, while robust, had relatively wide gear ratios that meant the engine often ran at higher RPMs than necessary. The final drive ratios were set to prioritize pulling power over cruising efficiency. Again, these were defensible engineering choices if you were designing for maximum performance, but they were poor choices if you needed to minimize fuel consumption. A comparison report produced by Aberdeen in September 1945 concluded that the Sdkfz represented excellent German engineering applied toward the wrong optimization targets. The report noted that if American engineers had been given the same basic requirements, tow 8 tons, carry 12 men, operate in all terrain, they would have designed a very different vehicle. The American approach would have prioritized fuel efficiency and ease of maintenance over absolute maximum performance. The post-war American military took these lessons to heart. When the Army began developing new generations of armored vehicles and trucks in the late 1940s and 1950s, fuel efficiency remained a key design parameter. American military planners never forgot the image of powerful German tanks abandoned by the roadside, out of fuel. They never forgot the realization that in modern warfare, the side that could keep its vehicles supplied and mobile would outlast the side that built more powerful, but less sustainable machines. The development of American vehicles in the 1950s showed the influence of these wartime lessons. The M59 armored personnel carrier, which replaced the M3 half-track, was specifically designed with fuel efficiency in mind. It achieved approximately 4 men per gallon, better than the M3 despite being larger. The M113 armored personnel carrier, introduced in the 1960s, continued this emphasis on efficiency. Military specifications for new vehicles explicitly included fuel consumption requirements. The contrast with Soviet vehicle development was interesting. The Soviets, who had faced similar German fuel inefficiency, but from a different perspective, came to different conclusions. Soviet designers operating in a nation with abundant oil reserves were less concerned about fuel consumption. Soviet armored vehicles of the Cold War era were notoriously thirsty, sometimes consuming even more fuel per mile than German World War II vehicles. But the Soviets had the fuel production to support this approach. The Germans had not. The economic implications of the fuel consumption difference were staggering when calculated over the entire war. American forces in Europe consumed approximately 300 million gallons of gasoline per month by early 1945. If American vehicles had consumed fuel at German rates, this figure would have been closer to 500 million gallons per month. The additional fuel requirements would have meant more tankers, more port capacity, more trucks, more of everything. It might have delayed Allied operations by months or even made some operations impossible. Germany, with far more limited fuel resources, could never have sustained American-style operations, even with American-level fuel efficiency. But with German-level fuel inefficiency, German forces were immobilized even when defending their own territory. Some historians have argued that Germany's fuel shortage was the single most important material constraint that determined the war's outcome in the West. German forces in the final year of the war were repeatedly unable to maneuver because they lacked fuel, not because they lacked vehicles or trained crews. The Sdkfz itself had a curious afterlife. Some captured examples were used by Allied forces for a few years after the war. The Czechoslovak army operated a number of them until the early 1950s. The vehicles themselves were soundly built and could run for years with proper maintenance, but they remained fuel hogs, and as soon as more efficient alternatives became available, they were retired. Today, a few surviving Sdkfzs can be found in military museums around the world. They are impressive machines, tall and imposing with their distinctive track suspension and powerful appearance. Visitors admire their robust construction and imagine them towing 88mm flak guns across European battlefields. But the museum placards rarely mention the fuel consumption figures. They rarely note that this impressive machine needed to stop for gas twice as often as its American equivalent. The American GIs who drove these captured vehicles in 1945 certainly remembered. Years later, in reunions and memoirs, some of them would recall the experience with a mixture of respect and amusement. Yes, the German half-track was powerful. Yes, it could do impressive things, but boy did it drink fuel. You could almost watch the fuel gauge dropping as you drove. There is a broader lesson here about technology and warfare. The most impressive weapon is not always the most effective weapon. Performance matters, but sustainability matters more. A tank that can destroy any enemy tank in single combat is useless if it cannot reach the battlefield because it ran out of fuel halfway there. A half-track that can tow the heaviest guns is a liability if it needs a dedicated fuel truck following it around. The Germans learned this lesson too late. By the time they realized that fuel efficiency needed to be a design priority, they were already losing the war and lacked the industrial capacity to redesign and rebuild their vehicle fleet. The Americans, perhaps through luck as much as foresight, had built their military machine with efficiency in mind from the start. When American soldiers climbed out of those captured Sdkfz-7s in the spring of 1945 and calculated how much fuel the big German tractors had consumed, they understood something that historians would spend decades analyzing. The Third Reich had not just failed strategically or tactically, it had failed logistically. The German military had built a force that required resources it could not sustain. The Americans had built a force that could keep fighting as long as the plummeting factories kept running and the ships kept sailing. The fuel consumption comparison was just one data point among thousands, but it was a revealing one. It showed that German engineering excellence, real as it was in many areas, had been deployed in the wrong direction. The Germans had optimized for performance in ideal conditions. The Americans had optimized for performance under realistic constraints. When the constraints of a multi-year global war made themselves felt, the American approach proved superior. In the end, the German Sd.Kfz 7 and the American M3 half-track told different stories about their nation's approaches to war. The Sdkfz 7 embodied the German belief that superior quality and performance would triumph. The M3 embodied the American belief that adequate quality combined with superior quantity and sustainability would prevail. History proved the Americans right. Today, when military historians analyze why Germany lost World War II, they cite many factors. The two-front war, the industrial capacity disparity, strategic bombing, tactical errors, ideological extremism, and countless others. But somewhere, in that analysis should be a footnote about fuel consumption, about how German vehicles burned through gasoline at twice the rate of American vehicles, about how American GIs could not believe how thirsty captured German half-tracks were, about how the mighty Sdkfz, for all its power and capability, needed to stop for gas so often that American soldiers started to see it as a liability rather than an asset. The German soldier who had operated an Sdkfz in 1941, racing across the steppes of Russia with captured Soviet fuel filling his tanks, probably never worried about fuel economy. There was always more fuel at the next supply depot. But the German soldier trying to operate the same vehicle in 1945, watching his fuel gauge drop toward empty with no supply depot in sight, understood the problem all too well. German logistics had not kept pace with German ambitions, and German vehicles had been designed with the assumption that logistics would never be a limiting factor. The Americans, more pragmatic or perhaps simply more aware of their logistical limitations, had built vehicles that could operate even when supplies were tight. An M3 could stretch its fuel tank to get to the next supply point. An Sdk7 could not. In the grinding attritional warfare of 1944 and 1945, that difference was decisive. So when we remember the mechanized warfare of World War II, when we think about half-tracks and trucks and the vehicles that moved armies across continents, we should remember the fuel consumption story. We should remember the American soldiers who climbed into captured German vehicles and discovered that German engineering excellence came with a hidden cost. We should remember that sometimes the most important victory is not won on the battlefield, but at the fuel pump. And we should remember that in a war where every gallon mattered, the side that built more efficient vehicles had an advantage as real and as decisive as superior tactics or better trained soldiers. The Sdk7 was a remarkable machine, but in the end it was also a symbol of why Germany could not sustain its war effort. Power without sustainability is ultimately weakness. Performance without efficiency is ultimately failure. American GIs learned that lesson in the spring of 1945, driving captured German half-tracks that kept running out of gas. It was a lesson that would shape American military thinking for generations to come.